All right, in P5, we are going to be using our graphing calculator to make our lives easier a little bit, as well as just some solving techniques for quadratics. So this first video will be focused on the ways we can use our graphing calculator. So two big concepts that we're going to deal with is either setting the equation equal to 0, or we'll set equations equal to each other. Those will be the two things we'll focus on in the video. So first thing is setting the equation equal to 0. Well, number one here already has that. So if I have my equation set equal to 0, the first thing I'm going to want to do is just put this equation into y1. So if I go to my graphing calculator, 6x squared plus 7x minus 3, we'll go ahead and put that in the calculator. And then a good thing to know about your graphing calculator is to always hit zoom and then option 6 for the standard view, just to make sure we get a good graph. So you can hit the number 6 and it will give you zoom 6, the standard view. So we see a parabola here. We should be expecting that with our x squared. And zeros on a graph happen where it crosses the x-axis. So we're going to want to find both of these. That is what we get to use second calc 0 for. So there's one right here. If I go to second calc, I have to hit second because the calc letters are blue on mine, probably yellow on yours. And then we'll hit trace. Option 2 is for 0, what we want to find. And it comes up with some questions for you. So this tells you what equation it's on. This tells you the ordered pairs of where it's at. This right here, though, tells you kind of what information does it need to know to calculate what you want it to. So left bound, I want you to think like left boundary. So left boundary, if I'm interested in this point, if I go up top, if I'm speaking from an x direction perspective, if I follow this all the way down, I see that this is just to the left of my 0. So this is kind of a left bound or left boundary that I want for my calculator to find this. Right bound, I'm going to go below because in a x direction, if I go up here, I see that it gets to the right of the ordered pair we want. So in the 0. So I want to make sure I'm to the right of it for the right boundary and press enter. You'll see that it's putting these right here. What your calculator is doing is it's saying somewhere between here is a 0, the left boundary and the right boundary. Now I'm going to figure out exactly what it is. So press enter again, and we figure out it happens at exactly negative 1.5. But what if I want to find this one to the right? I can repeat the steps, second calc, go down to option 2, but now the left boundary, instead of being up above, I still want to be to the left of this 0. So to be to the left of the 0, I have to be down below. I will press enter. Then to be to the right of the 0, I need to be up top. That's where my graph is. So I'll go up top, press enter, enter again, and now it tells me 0.3 repeating, or 1/3. Those are the two zeros. That's a way you can do that with your calculator and the graphing capabilities rather than just solving it out. So let's take a look at this. We're going to put this equation y2 like the notes say. We're going to put 3x minus 1 in parentheses and 2x plus 3 in parentheses. Then if I hit graph, how many graphs am I seeing? Because I've got two things in, but nothing new popped up. There is only one graph on here. So does factoring give exact solutions? Let's see. Well, if I see that these are the factors for this, I'm going to get the exact same solutions. So does factoring give the exact answers? Does it give answers that aren't rounded? Well, we will use some algebraic properties later, but here, this seems pretty exact. I know all the digits. Here, I could gather it from here. We'll get there, but yes, this could give exact solutions. The other option we said was instead of setting it equal to 0, we could set the equations equal to each other. So take a look at equation 1 and equation 3 here. The only thing that's different is the minus 3 got bumped over to the right side, and now it's a positive 3. So if I instead switch this up, so this is now y1 and this is now y2, let's see what happens. So we'll clear out what we had before. We'll have 6x squared plus 7x in y1 and 3 in y2. This is just the technique for setting them equal to each other to say where are these two things equal. So left side y1, right side y2 standard. So I get a parabola that looks a little bit different than the one we had before, and now I have this horizontal line. I am looking where they're equal. Where are they the same? Well, they're going to be the same at these intersection points. So that's why we want to do second calc, but now option 5 for intersect. So these questions it now asks us is, what's the first curve of the two that you need to intersect? So the first one is the parabola. I am on the parabola. Then you'll see the cursor jumps, second curve. It says, what's the second thing that you want to have cross? So maybe you need to scroll over to figure out that you're actually on the line. Enter, enter. There we get the 0.3 repeating for the one on the right. Let's try the intersection commands again to see if I'll get the negative 1.5 and see if I get the same solutions. But in order to get the next intersection point, I've got to make sure my cursor kind of has the things that I press enter on being close. So my cursor now on the parabola, I know that I'm closer to this intersection point than this one. So I will go ahead and press enter. Then as I go back to the horizontal line, again, I'm closer to this intersection than the other. So if I want to find this one, I want to be close. I press enter, enter again. Notice how I'm going to get negative 1.5 all over again. So even though the equation changed by bumping the 3 over, we're going to get the same answers. So now this one is a try it on your own. Whether you do the y1 equals y2 or you choose to bump the 4 over and do the zeros, I want you to try that one on your own and see if you get the answers. So pause the video. All right. You should have gotten negative 1.12 and 7.12 if you did that correctly. So make sure you're able to get that. If you have questions about it, make sure to come see me. So now if we don't want to do it with the graph finding intersections, there are other ways to get these answers looking at the table. This, though, is not as helpful as I want it to be. So if you want to talk about the table, come see me in person. I think that it's something I could better do. We'll have better examples of tables coming in the future. Just make sure you go over to the next video so we can start continuing through the notes, because this one is dedicated towards the graphing.